Think rockets are the only way to explore the cosmos? Think again! For more than a century, we've been captivated by the fiery spectacle of chemical rockets blasting off into the sky. It's the iconic image of space exploration, a testament to our ingenuity and our relentless desire to reach for what lies beyond. But let's be honest, rockets are, in a cosmic sense, slow, inefficient, and profoundly limited by the tyranny of the rocket equation. They're like trying to cross an ocean in a rowboat, a magnificent effort, but there have to be better ways. The universe is vast, and the distances are just, well, mind-boggling. To truly become a spacefaring species, we need to think bigger, bolder, and frankly, a bit weirder. We need to graduate from the fire and fury of controlled explosions and look to the very fabric of the universe for our next ride. The laws of physics, as we understand them, offer tantalizing clues and potential loopholes that could revolutionize how we get from here to there. We're talking about manipulating space and time, harnessing the energy of stars themselves, and even reconceptualizing what it means to travel at all. It's a journey that takes us from the realm of established science to the bleeding edge of theoretical physics, where imagination and mathematics dance together on the grandest stage of all. So, buckle up your curiosity and prepare to leave conventional thinking behind. Forget the booster stages and the massive fuel tanks. We're about to embark on a journey through the most audacious and spectacular concepts for interstellar travel ever conceived. From bending the space-time continuum to our will, to building worlds that wander through the void, humanity's future among the stars might not depend on a bigger bang, but on a smarter idea. Here are 5 mind-blowing ways we might travel the stars. No rockets required. First up, the one you all know from your favorite science fiction shows, the warp drive. But this isn't just a convenient plot device for television. It's a concept rooted in real physics, proposed by physicist Miguel Alcubierre in 1994. The idea isn't to travel through space faster than light, which Einstein's theory of relativity forbids. No, the trick is far more elegant. The Alcubierre drive proposes to move space itself. Imagine you're on a cosmic surfboard. The drive would create a warp bubble around the spacecraft by expanding space-time behind it and contracting space-time in front of it. The ship itself would remain stationary inside this bubble, completely isolated from the tidal forces and relativistic effects. It's space that does the moving, carrying the ship along for the ride like a wave carrying a surfer to shore. The beauty of this is that while nothing within the bubble breaks the cosmic speed limit, the bubble itself could, in theory, travel at multiples of the speed of light. You could traverse the 4.2 light-years to our nearest stellar neighbor, Proxima Centauri, in a matter of weeks or days, not millennia. You would arrive without experiencing any time dilation, meaning you wouldn't return to an Earth thousands of years in the future. You could pop over to the next star system and be back in time for dinner, cosmically speaking. It's the ultimate cosmic loophole, a way to cheat the universal speed limit without actually breaking the law. It's not about moving through space, but about bringing your destination closer to you. Of course, there's a catch, a rather significant one. To create this space-time distortion, you'd need a stupendous amount of energy. Even more exotic, you'd need something called negative energy or exotic matter, a hypothetical substance with bizarre properties, like having negative mass. We have no idea if such a thing can exist or how we would create and control it. It remains firmly in the realm of the theoretical, a mathematical possibility, waiting for a breakthrough in fundamental physics. But the very fact that the equations allow for it is a profound statement about the possibilities hidden within the fabric of our universe. If warping space-time sounds too much like hard work, how about punching a hole right through it? This brings us to our second concept, wormholes, or as they are more formally known, Einstein-Rosen bridges. Think of space-time as a giant sheet of paper. To get from one point to another, you could slowly crawl across the surface. Or you could simply fold the paper, bringing the 2 points together and poke a pencil through, creating an instantaneous tunnel. That tunnel is your wormhole, a shortcut, a cosmic subway system connecting 2 vastly distant regions of space, or even 2 different points in time. It's the ultimate express lane through the cosmos. The concept emerges directly from Einstein's theory of general relativity. The same equations that describe gravity and black holes also permit the existence of these topological tunnels. A trip that would take millions of years traveling at near light speed could be reduced to a simple step through a gateway. Imagine stepping through a portal in your backyard and emerging moments later on a planet orbiting a star in the Andromeda Galaxy, 2.5 million light-years away. The implications are staggering, not just for exploration, but for the very concept of a galactic civilization. It would make the entire universe our neighborhood. But just like warp drives, wormholes come with a user manual full of warnings. Naturally occurring wormholes, if they exist at all, are predicted to be subatomic in size and incredibly unstable, collapsing in an instant. To create a traversable wormhole, one large enough and stable enough for a person or a ship to pass through, you would again need that pesky exotic matter with negative energy density to prop it open and prevent it from immediately snapping shut. Finding or manufacturing this stuff is the great barrier standing between us and a universe of cosmic shortcuts. Are they a fantasy, or is there a future civilization out there that has already mastered this ultimate form of cosmic engineering? Let's come back from the far-flung edges of theoretical physics to something a bit more tangible. Solar sails. This method doesn't require negative energy or tearing holes in space-time. It relies on a principle we understand very well. Light, though it has no mass, has momentum. When photons from a star strike a surface, they impart a tiny, tiny push. It's an incredibly gentle force, but in the frictionless vacuum of space, that gentle push is continuous and unrelenting. A solar sail is basically a gigantic, ultra-thin, highly reflective mirror designed to catch these photons like a ship's sail catches the wind. It's not a chemical rocket, it's a photon rocket. Imagine a spacecraft unfurling a sail possibly kilometers wide, but thinner than a human hair. As sunlight or starlight reflects off its surface, the vessel would begin to accelerate. Slowly at first, but continuously. Day after day, month after month, that constant, gentle push adds up. Unlike a rocket, which fires for a few minutes and then coasts, a solar sail accelerates for the entire duration of its journey. Over time, it could reach speeds that are simply impossible for chemical rockets. We're talking about a significant fraction of the speed of light, potentially allowing us to reach nearby stars in decades rather than millennia. And you know, this isn't just science fiction, it's science fact. We've already tested this. Japan's Icarus probe successfully demonstrated solar sail technology in 2010, and the Planetary Society's LightSail 2 mission proved it could use sunlight to change its orbit around Earth. The next step is to scale it up. Imagine giant laser arrays based on Earth or the Moon, firing powerful focused beams of light at these sails to push them even faster and further, a technique known as beam sailing. It's a technology that bridges the gap between our current capabilities and our interstellar ambitions. It's elegant, efficient, and powered by the very stars we wish to visit. Now for a true leap into the bizarre and wonderful world of quantum mechanics teleportation. And no, I'm not talking about a machine that deconstructs you atom by atom and reassembles you somewhere else. That's just a fancy fax machine and a murder weapon all in one. I'm talking about quantum teleportation, which is a real, experimentally verified phenomenon. It doesn't transport matter, but rather, it transports information. It works through a spooky process called quantum entanglement, which Einstein famously called spooky action at a distance. You can link two particles in such a way that they share the same quantum state, no matter how far apart they are. Here's how it works. You take a particle, you want to teleport and entangle a third particle with one of the original pair. You then perform a measurement on the particle you want to teleport and the new particle. This measurement destroys the original state, but, and here's the magic, the information about that state is instantaneously transferred to the distant entangled particle, which then transforms to become an exact replica of the original. We've done this in labs, teleporting the quantum state of photons over hundreds of kilometers. The information transfer is instant, seemingly violating the light speed limit, though it still requires a classical signal, limited by light speed, to unlock the information at the other end. So, could we teleport a person? Well, that's a colossal challenge. You'd have to scan and transmit the quantum state of every single one of the 10 to the power of 27 atoms in a human body, an astronomical amount of information. And you'd need a stockpile of raw matter at the destination to assemble into the new you. It seems more plausible for transmitting information or maybe building things at a distance. Imagine sending the complete quantum blueprint for a robotic probe to an asteroid belt, where a pre-positioned 3D printer could then assemble it from local materials. It's not travel in the traditional sense, but a way to project our presence and our technology across the stars instantaneously. Our final method is perhaps the most epic and most human of all. It requires no new physics, no exotic matter, no bending of space-time. It requires only engineering, biology, and an extraordinary amount of patience and commitment. I'm talking about the generation ship. If you can't get to the stars in a single lifetime, then you design a journey that spans many lifetimes. A generation ship is not just a spacecraft. It is a self-contained mobile world. It would be a colossal ark, kilometers long, carrying a complete ecosystem, a closed-loop life support system, and a human population large enough to remain genetically diverse over centuries. The journey would be the destination. The original crew who left Earth would know they would never see their new home. Their children and their children's children would be born, live their entire lives, and die in the void between the stars. It would be up to their distant descendants, maybe 10 or 20 generations later, to finally arrive and step out onto a new world. This raises profound sociological and ethical questions. What right do we have to commit future generations to a life aboard a ship, a life they did not choose? How do you maintain social stability, knowledge, and a sense of purpose over a 1,000-year voyage? The engineering challenges are immense, from shielding against cosmic radiation to maintaining a perfectly balanced ecosystem for centuries. But in many ways, this is the most realistic of our interstellar options based on technology we can foresee. It doesn't rely on a physics miracle. It relies on human endurance, our ability to plan for a future we will not see, and our instinct to carry the light of consciousness forward into the great unknown. A generation ship is a testament to the idea that humanity itself is the vessel, and our journey is written not just in the stars, but in our own DNA, passed from one generation to the next. From surfing on waves of space-time and diving through cosmic tunnels, to sailing on starlight, transmitting our very essence across the void, or embarking on millennial journeys in world ships, the future of interstellar travel is a canvas of breathtaking possibilities. These aren't just idle fantasies. They are the product of our deepest understanding of the cosmos, pushing the boundaries of what we believe is possible. Each concept, whether it requires a breakthrough in fundamental physics or a monumental feat of engineering, tells us something profound about our own ambition and our place in the universe. We are a species that looks up and wonders. The rocket got us to the moon, and it will take us to Mars. But to reach the stars, to truly step out into the galactic neighborhood, we must become masters of the universe in a way we can currently only dream of. We must learn to manipulate space, time, and energy on a scale that dwarfs our current abilities. The path forward is uncertain, and the challenges are monumental, but the motivation is as old as humanity itself. The desire to explore, to discover, and to see what lies over the next horizon. The universe is waiting for us. The journey from here to there will be the greatest adventure we ever undertake. It will demand the best of our science, our engineering, our philosophy, and our humanity. The technologies we've discussed today may seem like fiction, but yesterday's fiction is often tomorrow's reality. The future of space travel is stranger and more exciting than science fiction. Which way would you choose to explore the stars?